All right, so here in section 3.2, we're going to give a little bit more detail about the F distribution. So the F distribution, called Fisher's distribution, is named after the English statistician Sir Ronald Fisher. The F distribution is generated by the squares of the corresponding values of the student's T distribution. The F statistic, okay, the test statistic, is a ratio between two degrees of freedom of the numerator and degrees of freedom of the denominator. The critical value also requires both degrees of freedom of the numerator and degrees of freedom of the denominator. The F distribution is non-symmetric, similar to the chi-square distribution, and it has positive values only. And just like the chi-square distribution, it does change shape. Okay, so it changes based off of two degrees of freedom of the numerator and degrees of freedom of the denominator, which are unique for every problem that you apply to the F distribution. Now, it's a lot less difficult to try and predict, maybe what the shape is exactly going to be. So here I gave two different examples. The figure 3 on the left is where I kept degrees of freedom of the numerator constant, and I only changed degrees of freedom in the denominator. So you can see as the degrees of freedom of the denominator got greater, the peak got greater and shifted to the right a little bit. Whereas with the figure 4 on the right, I kept the degrees of freedom in the denominator equal, and I changed only the degrees of freedom of the numerator. And, it goes from being this, looks like almost like a chi-squared type distribution when the sample size is low or small, to, kind of being similar to what we got over here on the other side. Okay, but it's really weird to predict. So you won't have to predict it to any degree like this. Just know that it's shape shifting and it's based off of two values. Okay, so I think that's it for the basics you need to know about the shape itself. Let me know if you have any questions.